Hi, welcome back to my channel. Today we will discuss on chapter 4 forces. So in this video we will continue with the previous one. In the previous video we already discussed questions 1 until questions number 5. So in this video we will continue discuss questions number 6. Okay, so for questions number 6, suppose the force 1000 newtons. So this force actually is a pulling force. This is actually our external force where it pull these three objects to the left. Okay, so meaning that the motion is actually to the left. So this is our motion. Okay, motion is to the left. Motion is to the left. And here we have M1, M2 and also M3. So the first one is determine the accelerations of the block system. Okay, so for M1, if you want to draw free body diagram, M1 is there is external force. We have also weight. We also have a normal force, and we have tension. Okay, M2 we have weight. We have normal force. We have tension T1 and tension T2. Okay, whereas for object M3, we have the weight, we have normal force, and of course we have T2. Okay, so when you want to draw free body diagram, you need to split into three diagram. Okay, three free body diagram. Okay, so now we want to determine the accelerations of the block system. So because we want to find the accelerations, so we can use F equals to MA. Okay, we can use F total. So when you want to use F total, M should use M total. Okay, A. So F total here, if you are referring to X component, this is for X component. Okay, we have F external, we have T1, we have T2. But if you observe, T1 will cancel each other because one to the left, one to the right. T2 also will cancel each other. Okay, so meaning that F net total for X component, we only have F external. Okay, we only have the pulling force. Okay, M total, because we are using total, so we need to use M1 plus M2 plus M3, M total for the whole system, and acceleration. So we substitute into the equations. 1000, M1 is 3, M2 15, M3 is 30. Okay, times the acceleration. So therefore, the answer for the acceleration is equal to 20.8 meter per second square. Correct unit. Okay, you must have correct answer with correct unit. Okay, for B, we want to find the tension T1 and also T2. So we can use for the first object first, M1. So we can draw the free body diagram for M1 where we have tension T1, we have the weight, we have F external, the pulling force, and we have the normal force N1. Okay, so this is a free body diagram for M1. And remember, all the line must connected together. Okay, and then you must draw an arrow as well, and also labeling. So for X component, Fx equals to MA. So now because we are using M1, so F here is MA, F also F1, acceleration. Okay, so the motion, just now we already know that the motion, because it is pulled to the left, so meaning that the motion is to the left, so anything to the left or same direction with the motion will be positive. Okay, so meaning that for this case, our F external is positive because the direction of X external is similar with the motion. Okay, minus tension T2 because T2 is opposite direction, equals to M1A. So F external is 1000, T1 we don't know, M1 is 3, A is the value just now from the questions number A. Okay, so therefore we will have the first T1 equals to 937.6 Newton. So this is T1. Okay, next we go to find T2. So we can use the object M2, or you can use object M3 also can. So okay, if let's say I use object the wooden block M2, so we must draw the free body diagram first. We have T2. Okay, we have the normal force, we have the weight M2, and of course we also have T1. Okay, so because we want to find T2, so we use x component to find. Okay, F2 x component is equal to M2 acceleration. Okay, so again, because the motion is to the left, so any forces that same direction with the motion is positive. Okay, so T1, because it's same direction with the motion, so we take T1 minus T2 equals to M2A. T1 just now, we already found 937.6 minus T2, we don't know. M2 is 15, A is 20.8. So therefore, T2, the answer is 624 Newton. Okay, if let's say you want to use M3 to find, also can. So M3, we have T2, we have the weight, we also have the normal force. Okay, so when you want to find T2, you can use F for the third wooden block equals to M. Of course, M is M3A. Okay, so for this case, x component, we only have T2. So you can write T2 equals to M3A, where your M3 is 30, A is 20.8. So you will also get 624 Newton. Okay, similar like just now when we use wooden block, the second wooden block. Okay, so you'll get the same answer. Okay, next we go to questions number 7. Okay, you may pause the video if let's say you want to do it. Okay, or I'm going too fast, you can pause the video. Okay, next one is questions number 6. Two objects, mass M1 and also M2, are tied to a light string and at rest. Okay, at rest on the smooth horizontal floor. Okay, as shown in figure, determine the horizontal force P acting on one object so that the accelerations of both objects is 4 meters per second squared. Okay, so meaning that this force for P, the FP here is the external force. It's also a pulling force, pull M2. Okay, so it will accelerate to the right with the accelerations of 4 meters per second squared. So meaning that if the force similar motion with the acceleration, it will be positive. If opposite direction, force is negative. So we draw free body diagram for M1 and also M2 first. Okay, so for M1, we have the weight, we have tension, we also have the normal force. Okay, and because the question said it's a smooth surface, meaning that there's no frictional force. Okay, next we go to M2. Okay, M2, we have the external force, we have tension, we have the weight for the second object, and also the normal force. Okay, so next what should we do is we use the total first because we want to find P. Okay, so we can use F resultant or total equals to M total A. Okay, where F total for this one, we can use okay, is equals to FP, is equals to FP. Okay, because T and T here will cancel each other. Okay, so if you don't understand, later if you substitute also, you will get the same answer, plus T minus T plus T, so actually they will cancel each other. Okay, equals to M1 and M2, 50 plus 150, acceleration is equals to 4. So our F external P is equals to 800 Newton. Okay, next one, calculate the tension. Okay, tension either you can use M1 or you can use M2. For example, let's say I use M1. So M1, the free body diagram is tension. We have normal, and also we have M1, the weight one. Okay, so now when you want to find the tension, you must use X component because tension is X component. For 1 equals to M1A. Okay, so for this case, we only have tension. Okay, equals to M1 is 50, A is 4. Okay, so you will get 200 Newton. Okay, so you get the answer. Okay, if let's say you want to use M2 also can, you will get the same answer. So M2, you need to draw out the free body diagram where we have F external, we have tension, normal, okay, and also we have weight 2. So again, when you want to find T tension, you must use X component, because it's at the X component. Okay, equals to M2A. So for this case, because the motion is to the right, so we take F external minus T equals to MA. Okay, F external is 800 minus tension equals to M2 is 150. Acceleration is 4. So therefore, our tension is equals to 800 minus 600. So you will get 200 Newton as well. Okay, you will get the same answer. Okay, next one we will go to questions number 8. Okay, questions number 8 is two objects of mass M1 and M2 are connected by a light string. So M1 and M2 are tied with the same string. Okay, which pass over a smooth pulley. A smooth pulley meaning that there is no frictional force acting on the pulley. So the first one, you must draw free body diagram first. Let's say M1. So M1, we have weight 1 and also we have tension. Okay, for M2, we have weight 2 and also we have tension. Okay, of course T1 and this T, they are from the same string, so that's why the tension for both also same. So okay, first questions, find the accelerations of the object. So again, we use F total, okay, equals to MA. Okay, so if we are referring to the whole system, the whole system is this one is going up, this one is going downward. Okay, so we can take, if let's say we take this one, the motion for the pulley is this one is going up, okay, for this one is going downward. So F total here is our tension going up, okay, minus our weight 1, okay, and then for object 2, the motion is going downward, so plus weight 2, tension, because it's opposite direction, so it's minus tension, equals to M. Of course we use total, so it's 10 plus 15 times the acceleration. Okay, so if you observe here, our T and T, we can cancel each other because they are from the same string. So we only have M1, weight 1 and also weight 2. Okay, weight 1 is number 1 is 10. Okay, negative times 9.81. Weight 2 is 15 times 9.81 equals to 25A. So your A, you will get 1.962 meter per second square. So this is the answer for acceleration. Okay, next you want to find the tension. So if you want to find tension, either you use M1 or you can use M2. Okay, if let's say I use M1, so the free body diagram for M1 is tension, and this is the weight 1, and the motion is upward. Okay, so any force that's similar with the motion, will be positive, opposite direction is negative. So our F here, of course, we take Fy because it's Y component equals to M1A. Okay, so it's tension minus weight or weight minus tension. For this case, it's tension minus weight because the tension is similar direction, same direction with the motion. Okay, equals to MA. So tension minus weight is 10 times 9.81 equals to 10. Acceleration is 1.962. So therefore tension you will get 117.7 Newton. Okay, so this is the way you find tension using the M1. Okay, if let's say you want to use M2, of course you'll get the same answer. Okay, if let's say you want to use M2, you draw the free body diagram where we have tension, we have weight 2. But for M2, the motion is acting downward. Okay, so meaning that our weight 2 minus tension. Okay, because the motion similar with weight 2 is equal to M2A. Okay, weight 2 is 15, 9.81 minus tension equals to 15. Acceleration is 1.962. So therefore, you will get the answer for the tension is 117.7 Newton as well. Okay, so you either one, you can use M1 to find or you can use M2 to find the tension. Both you will get the same answer. Okay, next one, questions number 9. Okay, questions number 9, there's a two object A and B connected with the light string. Again, this tension T here, let's say I label T1, and the tension T2 are the same T. T1 is actually equals to T2. So now we need to draw free body diagram first before we start to find the answer. For A, we have the tension. Okay, we also have the weight. We have the normal force because there's a contact with the floor, and there's a frictional force. Okay, because it's a rough surface, so frictional force is opposed to motion. So the motion is to the right, and the motion will go downward. Okay, for B. Okay, meaning that the frictional force is opposite direction, so it will acting to the left. Okay, so this is free body diagram for A. Okay, for B, the free body diagram for B is we have the weight for B, we have tension T2. Okay, and we don't have the normal force because there's no contact with the wall. We don't have the frictional force, and we don't have the external force. Okay, so now we want to find the acceleration. Okay, we go to object A first. Object A, the free body diagram for object A is tension. We have normal, we have the weight A, and also we have the frictional force. Okay, and the motion is for A is to the right. Okay, so if you want to find X component, okay, equals to MA. For X component, for object A is tension minus friction because the motion is to the right. So tension is similar, so we write tension minus friction equals to MA. M is 20A. Okay, and the frictional force is 4, so we can substitute inside. Our T equals to 4, our T is equals to 20A plus 4. So this is our first equation. Okay, next one for object B. Object B, we only have two forces where we have the weight B and also tension. I just label tension because T1 and T2 are the same T. So I just label it as tension enough. Okay, because they are from the same string. Okay, and for B, the motion is acting, the resultant is acting downward. So we will take weight for B minus tension because opposite direction equals to MB for times A. Okay, so weight for B just now here, weight for B is 4 kg. So we can write as tension, equals to weight for B is 4 times 9.81 minus 4a. Okay, so this is our second equations. So here we have two unknown t, a. Here also we have two unknown t and also a. Okay, so we can do it simultaneously where we can substitute into the equations. Okay, so we substitute equation 1 into equation 2. Okay, so 20a plus 4 is equals to 4 times 9.81 minus 4a. Okay, so this one you shift to the other side. This one you shift here. So you will get 24a equals to 4 times 9.81 minus 4. Okay, so therefore our acceleration you will get 1.47 meter per second squared. Okay, so after that you found your a, you can substitute back to equation 1. So from equation 1, t equals to 20a, you substitute 1.47 plus 4, then you will get your tension equals to 33.4 Newton. This is questions number 9. Okay, next one, we will go to questions number 10. So questions number 10, two frogs add on an object of mass 2 kg which is placed on a smooth horizontal. So smooth horizontal surface meaning that there is no frictional force. Okay, so for this one, we need to draw free body diagram first. Okay, here we have mg, we have two forces, okay, which is 6 Newton and also 10 Newton. So this is actually external force, is a pulling force, and also we have the normal force. So if we draw out the free body diagram, we will have the weight, we have the normal force, we have 10 Newton and also 6 Newton at the angle of 45 degree. Okay, so this is our free body diagram. Okay, after you draw the free body diagram, you can resolve it. Okay, the question asks us to find the acceleration. So at the accelerations, the motion is to the right. Okay, based on the questions, meaning that any forces that are same directions with the acceleration, with the motion, will be positive. Okay, so we write Fx equals to ma, x component first, because accelerations, the motion is x component. So for 10 Newton, we can resolve it into to the right or upward. Okay, for 6 Newton is to the left and upward. Okay, so Fx is for x component is 10 cos 30 because it is similar direction, same direction with the motion. So minus 6 Newton cos 45, okay, equals to ma. M is 2 accelerations. Okay, so straight away you can find the acceleration equals to 5 meter per second square. Okay, sorry, it's not 5 meter, it's 2.21. Okay, so the acceleration for questions number 10 is equals to 2.21 meter per second square. Okay, next one, we will go to questions number 11. For questions number 11, similar, there is two blocks A 10 kg, block B is 30 kg, are side by side in contact with each other. Okay, so when we contact with each other, there is a reaction force. Okay, there is a reaction force between A and also B. They are pushed along a smooth floor under the actions of a constant force. So of course this constant force here is actually a pushing force. It's an external force. Okay, this is actually the external force, pushing force applied to A only. Okay, so determine the accelerations of the block. Okay, so before you find the answer, please draw free body diagram first. So free body diagram for A is we have X external, we have normal force, okay, we have the weight. Okay, of course here there's a contact, so there is a reaction force acting on object A. Okay, from object A from B, so there is a reaction force acting from B to A. Okay, B to A. So if I draw for object A, the free body diagram for object A is F external. Okay, so all the forces must start from the origin here. Okay, so F external come out from the origin, so we label it as F external. And there's a reaction force, so this is the reaction force from B to A. Here is a normal force and also weight for A. Okay, so this is the free body diagram for block A. Okay, free body diagram for block B, we have the weight, we have the normal force, and again because they are touching each other, so there is a reaction force from A to B. Okay, so for free body diagram for object B, okay, free body diagram for object B is equals to from A to B. So I label as the reaction force from A to B, and we have the normal force, and also we have the weight for object B. Okay, so this is a free body diagram for A and also B. Okay, of course the motion is to the right. Okay, the motion is to the right. Okay, now we want to find the accelerations. Of course we can take total. Okay, it's easier for us to take total. So I write F total equals to M total A. Okay, so F total, if we are referring to this free body diagram, X component, for X component, okay, for X component, we have the reaction force BA, we have the F external, we have the reaction force from A acting on the B. Okay, so because RBA, the magnitude is actually equals to the magnitude of RAB. The value same. Okay, it's just that they are in opposite direction. Okay, so I put negative. Okay, they are same magnitude but opposite direction. So as a resultant, we only have F external. Okay, because FBA cancel off with the resultant force AB. Okay, so it's equals to 10 kg plus 30 kg A. And the external force is 200 just now, so we take 200 equals to 40 A. Acceleration will equal to 5 meter per second square. Okay, for part B, we want to find the force exerted by A on B. Okay, by A on B. So we want to find RAB. Okay, so it's easier. RAB, we use the free body diagram for B. So we use B. So BF equals to MA. Okay, why I use Fx? Because RAB is at the X component. That's why I use X component. Okay, so for X component, for object B, only RAB only. Okay, we only have one force acting to the right. Okay, equals to M. For B is 30, acceleration is 5. So therefore, we will get 150 Newton. Okay, so this is the answer for the force exerted by A on B. Okay, so that's all for this video. The next questions you can watch in the next video. Okay, thank you class. See you on next video. Bye.